Nice. Okay, cool. So I think last time we left off, we had our game engine running, and being able to kind of create a window and close, and it being somewhat platform independent, and we're going to kind of be continuing with that. So I actually recently watched a video by a YouTuber called Magical Bat talking of arena allocators, and I want to implement my own arena allocator, and I want to make sure it's kind of independent, platform independent. So to make it platform independent, so kind of just as a reminder, currently where we're creating our window, when we create our window here, we are writing it to dynamic memory. So we're saying, hi operating system, give us some dynamic memory using malloc, and we're going to return a pointer to the beginning of that block of memory. And what an arena allocator is we're just going to ask the operating system once at the start of the engine, hi, give us 2 gigabytes of continuous memory, and return a pointer to there, and we're going to be in charge of divvying up that memory ourselves. So I think the way we're going to do that is by this virtual alloc function. So this is the only window window dependent stuff. So this will have to go into our platform. So I guess what we'll do is we will have, I think we'll have an idea of a memory block and a arena memory. Let's call it memory chunk. And I guess let's actually create a util function, a util header where we can just put some stuff that we can use across other files. So we're going to have things like I want to use like stood in, right? So let's include stood in h. So that should mean we can like because we want to have like a standard width integers, and we know we're using the correct width integers. So I should be able to say, oh my god, if I can type, define, we'll do like u8 as u32t. We'll just use kind of these ones for now, I suppose. We can do all of them at some point. And then we'll go back to our we'll include this util.h. And now what we can do, oh god, is we can say that we want a pointer to the beginning of the memory chunk that we've allocated, right? And we also want the size of the memory chunk. And then here in our platform API, we're going to have something that returns this memory chunk. So now we'll call it init memory, and we want to just kind of give it a size, I suppose. Yeah, so at the moment we basically need our platform layer to divvy out a big chunk of memory. Then we'll make arenas from that chunk of memory, because this memory chunk here, initializing it is actually going to be non-platform independent, right? Because we're going to use virtual alloc, so this has to be part of our Win32 platform now. And then for Linux, this init memory will be a different function call. So then maybe I return the memory chunk though, so I guess the memory chunk needs to be in here, right? And because does this include platform header? So this doesn't, so let's delete this line. Yeah, so I think actually this stuff needs to, I guess what we can do is just define, because the thing is that is kind of fine, right? But we don't necessarily need to define it in here. Because this stuff has to kind of go here, right? And then here we're just going to, like we do with platform window, just give a vague idea of like this memory chunk, so that we can define our API. And then here we can have our functions signature again, so memory chunk, Win32 init memory, and we said I had a signature like that. Okay. So I guess we could now have to actually write it. So memory chunk Win32 init memory size t size. Okay, so what do we need to do? We kind of just need to virtual alloc, right? The memory and yeah, apologies, I made a few notes on this because this is quite new to me as well. So I guess we're just going to create our memory trunk struct, and then we want to then ask virtual alloc for our memory, I suppose. So we're going to say memory dot in the begin. Pass it to a U8 pointer. Virtual alloc. Okay. And what do we need? So we need the size of it. So we've already established what the size of our this one's right. It's LP void. Oh, so it's the starting address. Okay, so I think the way it does is, so when we're paging in memory into our virtual memory space, I think that's where the virtual memory space starts. I think because we can just say 0 for that. Because I think you can just give it arbitrary numbers and it'll page from that address to the end of the virtual address. And so I guess we'll just start at 0, is that correct? Okay. So DW size is going to be size. The type of memory allocation this parameter must contain one of the following values. Okay. So we're gonna mem reserve it. And then we're gonna commit the memory. So we're gonna set both these flags. Yeah, so we set these bitwise, all these flags together. And this parameter is specified from the indicator, sorry, and then the allocation type. So the type of memory allocation this parameter must contain, wait, that's what I just did. The protection level, oh, okay. The memory protection of the region of the page to be allocated. If the pages are being committed, you can specify any one of the memory protection constants. So we want to I think we want a page be right. Page read right. Okay. So what we've done is we've said two windows in our virtual memory space give us this sort of memory and commit it. I don't think it actually does until it's first touched, so we have this space, but I don't think it'll be using all of that quite yet. And it's giving us a U8 pointer, just so it's like the width of a byte, so that'll be easier for us to kind of play with. And then I guess memory.size is just going to be equal size, and then we want to return memory. In fact, I don't know why I capitalized this. Oh, I'm just going to call this mem. Right. Oh. Okay. So basically we should have asked Windows to give us all this memory space, and now we can kind of pass that to our arena. Or we can create arenas from this memory, right? We can give it specific points in this arena. Alright, so I guess what we'll do is we'll just create an arena header, and this is going to be become independent. So we're going to have some structs called arena. And so what does an arena need? Well, we need firstly a pointer to the beginning of the arena. So we are going to need our utils, and so we can once again have this kind of like bite-sized pointer, and this also is going to be called beginning. What else do we need? We're going to need an offset. And so this is kind of where the current pointer, so it'd be like the beginning plus the offset is where currently the pointer is in the arena. But what we don't want is begin plus offset to be greater than some capacity. So we need to give this arena a fixed capacity as well. Yeah, and that's actually what we need at the moment for our arena. Cool. So I guess the way we will do this is we can initialize our arena by passing do we want to I guess also one way we can do it is we can do something like void init arena, where you pass a reference to an arena and you want to give it some fixed size, right? So we can do something like this. Actually, I've completely forgotten the one rule. So one thing that you kind of have with arenas is you can have this idea of, do you need to kind of destroy them because they can just kind of run for the entire life cycle of the program. I guess for completeness sake though, I probably should have here some void function that will destroy memory when you pass in a memory chunk, right? And then in here it will be win32 destroy memory and let's have a think how we destroy memory. So normally you would destroy memory by having some malloc, right, of like some byte size, and then you can free that memory. With the to destroy memory, memory chunk. I guess we could have some return value there. I guess we have Win32. Just destroy, if I could type. Destroy memory. Memory management. Okay, so it's just kind of the same thing, virtual free. Okay. So actually looks like it will return. Thinkable is an int, and so we can just return virtual free dot begin mem dot size, and then I guess we decrease with region creators. Right, for now, let's just mem decommit and mem release. But we gotta make sure. So I guess this means we can. Oh. I probably want to have in equals destroyed mem do we want to actually do that? Let's just see. I haven't really fixed anything, so it's probably going to complain at me. But we'll have a look what it's complaining at. Well, that's because it probably can't spell. Destroyed. U8 undeclared identifier in platform.cpp. But that is because we have to define in here, we want to also include our util.h. Okay, we're compiling. That's cool. That's good. That's a good start. Okay, so we're going to be having our memory allocated, and we have a way to destroy it. But now we're going to focus more on the arena. We're going to take a different approach just to see. So if I want to pass it an arena, that we can like divvy out the memory. guess because we're in the I'll come back to that. I'm having a bit of a blank on where to go with that. So one thing we need to be able to do is kind of align our arena. And so when we kind of have so we have this memory that we want to divvy up, and we want to return a void pointer to the beginning of our available memory. But there is some things kind of we need to check about doing that. So if we have our arena memory and say we want to divvy out a certain region, we need to kind of make sure a few things. Firstly, that we're aligning our memory. So I think memory wants to be aligned with like the word size, and kind of an easy way to kind of see this is if you have some struct, and I think if you were to have something like int int a char b int c, I think this is going to be like 4 bytes let's say it's like this. This struct actually I don't think will be 9 bytes. What I think this will do will be 12 bytes, and the reason for that is this integer wants to sit on the beginning of the integer wants to sit on a memory space that is divisible by 4. And so what happens is this character is in a memory space that's divisible by 4. And basically what the compiler will do is going to end up padding this just so that this int can be sat on this 4th byte. But if you were to do something like this, this will, I believe, be 9 bytes. And so that's what we need to kind of do. We need to kind of make sure our memory gets aligned with like the word size of it. So we're going to write our own arena malloc basically. That's going to return a void pointer. Arena malloc align. And what do we need? Well, we kind of want to have some arena, right? And some how many bytes to assign, and then we want the alignment. Okay, so we have a function that initializes the arena, divvies up memory in that arena. We also want to be able to arena 3. Okay, so we'll take in an arena. Well, our OS is going to be doing the actual freeing, I suppose, so we're actually going to just reset the arena, right? So one cool thing you can actually do with arenas is you can actually just change this offset back to the beginning and basically override what's already in the arena. So you don't have to like deallocate the memory, just overwrite it. And then you can actually, because we're adding stuff to the arena, you can think of it as a as kind of a stack of items sitting on our memory. So we can kind of pop off the last thing off the arena. I don't really like doing that, but it's something you can do. So we will have an ability to pop from our arena, and the bytes, the amount to pop off. So I think we want to probably actually want to pass in a pointer here to the beginning, because our operating system would have virtual allocated the memory, and then we'll have a pointer to the beginning of our arena. Okay, let's actually implement some of this. So we're going to include arena.h void. Obviously, I have now forgotten an arena. Init arena. We're going to take in our arena, our pointer, begin, and the size. Yep. Okay, so easy enough. It's just arena begin equals begin. Arena dot the offset is 0. And the arena capacity is size. I just realized obviously I'm passing my reference, so you can just do it like this. And then if they want to return anything, you just edit it in place in memory. Fine. Let's actually take a little bit of a detour about how we're going to do our alignment issue. So I think we want to have a default alignment, and when I've seen people do this, we define a kind of a macro constant of a default alignment. I think for most systems the size of a void pointer is going to be equal to the default alignment. So I think on this system, I believe it's going to be like 8 bytes for a 64-bit operating system. Oh. I hope. But that is what I've read online, and I'm going to trust that. Right, so one thing as well is when we're aligning, we also want to make sure that our alignment is of power of 2. We don't want to align it onto a third byte, so we need some macro to return is this power of 2. Right. Let's actually do it like this. It is power of 2, and we can do kind of some bit manipulation. To say whether or not it's a power of 2. So basically what we can do is we can do something like if we have x minus 1, then what that means is if in terms of bits, let's say we have, so this is 1 in represented by 4 bits, and minusing that from some other x, say like this, if that in bits will flip this previous bit. Right. So what we can do is if we can check this last bit basically. And we can bitwise AND them together. And if this returns 0, then it is power of 2. And then if x bitwise AND x minus 1 returns 1, then it's not a power of 2. So we can do a bit of bit manipulation here. Let's just absolutely just wrap all these in brackets so that it expands correctly. Okay. Okay, so the next thing we kind of need to do is our alignment. And basically, what we want to do is to push all, we want to do some kind of pointer arithmetic to basically say if our pointer is not on the correct alignment, so if it's not on a memory address divisible by our default alignment, then we want to push it up to the next one. So for example, if the memory address is actually 2 mod our default alignment, then we want to push our alignment up to the next space, and we'll just pad that memory. I always forget how to do this, so I have it written down, bear with me. And the way we do that is with this macro here. So all this is basically just adding the word size to our pointer, and then kind of bitwise ANDing with the negation of it. And basically all that does is it just says if you add the alignment to it, are we into the next buckets basically, and if so, then bring it back down to the nearest alignment, and if it ends on the border of like the next bucket, then we were already previously aligned. Yeah, pretty hard concept. It's not that intuitive, but how would I best thingy this? So let's say we have our byte size, right? So we have our 8 bits. And let's say our memory address was here, then what basically we would do is we would add the byte size, which will push the pointer to here, and we are now, as you can see, in this next area of memory. And so what we would have to do is we'd have to line on this boundary here, and everything previously will just be like padded. And that's what that macro does. Okay, so with these tools, we can kind of divvy out some of our memory. So we want to return a void pointer. What did we call it? Arena by like a line. Arena. Let's just take what we're doing. Just not use line. Oh. Okay, so first we want to check if it is a line or a power of 2. So I think for now we'll assume that it always is, but we can say like if not, if is power 2 doesn't equal 0, then we will just return a null pointer, I suppose. if it is power of 2, we can just have to do this. We'll just say this. If it is power of 2, return if and we'll negate it like we were going to. Right. So we have our arena, and basically what we want to do is get our current so like, have we divvied up this arena before, and if so, can we get our current position? Because we don't actually hold the current position. What we hold is the beginning and offset, and so the current memory address would be a combination of these things. So let's cast this to UN points. So we do some pointer arithmetic on it, and we want to say that our arena dot begin, right, plus our arena dot offset, and that is currently where we are in the pointer. So that's where the next place of memory that we can assign is. But having said that, this current pointer might not be aligned with our current alignment word size that we've passed, and so to make sure it is, we are going to pass this current pointer into our alignment, and it will either pass back where it is currently or with some padding. So now we need to figure out this new offset, and so all we do for that is we have this new pointer, this align pointer, and we want to just see how far away it is from the start plus the bytes. So basically what we're saying is, whereas our new offset, well, it's the start minus some of the alignment plus the bytes. So it's the alignment minus the start plus some of the bytes. So we're kind of incorporating our new alignment of this pointer to the start. Because if we just, because what happens if we were to not account for our alignment here, we might overwrite the memory region and start writing into memory that we're not allowed to. And so that's why we now need to check that if our new offset is greater than the capacity of the arena. Here I want to return a null pointer as well, maybe. Obviously we won't know where our null pointers come from, and so not the best way to, you know, the top one maybe should be in a set of some sort, but for now we'll just do it like this. And so now we want to update our arena. If we have capacity to align this memory, we want to update this offset to be our new offset, I think, and we want to then return this pointer aligned to that the program can use here how it wants to. We use it as a void pointer because we're not going to be traversing it, and it will be cast as appropriate pointers when needed. So right, what other? Okay, so arena reset. So we don't actually have to deload anything. like let's say we just kind of want to just kind of say, oh, we're gonna just like quick reset this arena, to be used elsewhere. Don't, like I said, don't have to free any of the memory. What we can do is this: we can say arena dot offset equals 0. So we just basically reset the pointer for the offset back to the start, and everything that will then end up getting get overwritten. Right, I think there was one more function in this arena pop, but we'll deal with that another time. What I want to do is incorporate this into our main function. So what we want to do is, into our platform API before, we now have this new these new functions, init memory and destroy memory. Right, and we read them here. So win32 init memory, win32 destroy memory. Win32 init memory and win32 destroy memory. So what we should be able to do now is get a memory chunk, by saying init memory, it just needs don't get used to Vim. It just needs some size. So now this now will initialize 1024 bytes, so kilobyte, right? Am I just misremembering that? And what we can do is our memory chunk. So we are going to include here our arena.h. Okay, so we have this memory, and then what we can do is we can now make, let's say, a window arena, right? Screw it, let's just call it game engine memory. Alright, and this is where our window is going to sit. Okay, so then we want to initialize this arena, right? Let's just first put it as 0, and then we want to initialize our arena. We're going to pass in our engine memory, and we want to this doesn't have to be, this could be mem.size of 2, you can just give it all half of it. Okay, so now we have our oh, what's this, not like this, and destroy memory, near arena, no match vegetable in the arena. Oh, I didn't even call it start, I called it begin. Okay, in memory, not found, fine. What did I call that? Yeah, fine, because it's part of the platform API. Um, 21 arena.cpp. Can I just change this? Oh, because it's begin. I changed it to start, didn't I? 34. Void and arena cannot convert arena to arena pointer. Oh, okay. Because I'm being an idiot and I just need to pass in the actual thing. Going to destroy memory. Reference in a function. Fatal link. Can't link this. Okay. So destroy memory. Actually, how about that? So at the moment, 1, 2, 3, 4. I'll destroy memory. Is this going to be Win32 destroy memory? Win32 destroy memory chunk. Boom. Win32. So it doesn't like that Win32 destroy memory, probably because we have have in this memory chunk, right? And this signature maybe doesn't align with this one here. Destroying memory. It returns an integer. Maybe for now, just because I'm actually using this, I'll debug that another time and see if this works, which it does. So we init our arena, so we have now memory aligned and so now we need to, in our init engine, in our platform.h, so in our init engine, we now want to take in, we'll take in a pointer to an arena. Surely, platform.h we can just include in here. Right, and then in our engine we have our arena, and then we want to create a window. Create window is going to take in our arena. Now this doesn't know what arena is, so actually this now needs to include an arena .h for it to know what an arena is. Fine. So instead of malloc, right, we just have our platform window is going to be equal to platform window of arena malloc align of our arena. let's just do 32 bytes, right? And then default align. Where is our init engine? Right, so engine, engine CPU has this. Because we bootstrapped the wrong thing now, I think. So, where is it? No platform.h here, look. So this platform window create window needs to take in an arena. Ooh. And it compiles. And there is our window. And our window is now written into memory that is controlled by our arena. And yeah, I think that is a pretty good place to stop. So yeah, cool. Thanks everyone.